We are now going to talk about the policy-based routing, or the PBR as it is sometimes called. PBR is the way in iOS in which we can go beyond the default destination-based forwarding. Now, what is destination-based forwarding? In the IP world, the primary lookup key for forwarding the traffic is the destination IP address on the packet that is being forwarded. In some cases, this is not exactly what we want to do. In some cases, we want to perform a different kind of forwarding. So let's take a look at one example. Let's say that we had two routers, R1 and R2, that are directly connected. And let's add the third router to the mix. Let's say R3. And here behind R2 and R3, let's say that I had some network N. Now, when the traffic arrives and it goes to network N, it will follow whatever the routing table on R1 says. And let's say that the routing table, our routing information base RIB, says that this traffic needs to be forwarded via R2. So all the traffic going for the destination N will be forwarded out of this interface with this next hop here. But what if we wanted to take a look at the traffic that was, for example, coming from a specific source IP address? And if this source IP address is present in the IP packet, let's make sure that this traffic actually goes towards R3. So I want to override the default behavior. What I want to do here is I want to make an exception. So what we need is some sort of an exception-based routing. And in iOS, this exception-based routing is called the policy-based routing, or the PBR. So let's take a look at the example that I have here. Let's say that on interface X, if the source IP address is Y, let's send this traffic towards the next hop of Z. So the way I can do that is I can define an access list 1, and this is a standard access list, which means it is going to match against the source IP of the traffic. And here I'm specifying the host 10.0.0.0.1. So this will be my source, the source that I'm interested in. And then I'm going to define a route map, and I'm going to call route map PBR, but I could have called it anything that I like. And here I'm going to say match IP address 1. Now, this match IP address 1 simply means match the access list 1, and because this is a standard access list, it will match against the source IP address. So basically what I'm saying here is match source, and if the particular source 10.0.0.1 is matched, I'm telling my router to use the next hop using the command set IP next hop 192.168.10.1. So I'm telling the router to override whatever the information in the routing table would have been for this particular case, and I'm saying that this is going to happen. But this is going to happen where? Well, I'm interested in traffic arriving on interface gigabit 1. So this is my interface X. If the traffic is arriving on interface gigabit 1, I'm going to apply this policy, which means that if this source IP address is matched, I'm going to send the traffic towards the next hop of Z. So I have satisfied my requirements. Now, I understand that this may not be easy and straightforward to understand, so let's take a look at this in real example. To do that, I'm going to build a test network, and this is not going to be a small network, it's going to be a little bit involved. So I'm going to have R1, which is going to be connected to R2, and R2 will be connected to routers R3 and R4. Behind R3 and R4, I'm going to have a shared network to which I'm going to have some host connected. Now, this is going to be interface gigabit 1, and the IP address in here will be 192.168.12.0/24. This will be .1, and this will be .2 here. I'm going to have the network 192.168.23.0/24 here, and this is going to be .2 here and .3 here, and this is going to be interface gigabit 2, and I'm going to use sub interfaces here. So this is going to be gigabit 2, 23, this is going to be gigabit 2, 24, gigabit 2, 24, and this is going to be network 192.168.24.0/24. The network here, this shared network, will be 10.100.100.0/24, and here this will be gigabit interface 3, gigabit interface 3.3.4, and here I will have .100. So the IP address of the host will be 10.100.100.100. So this is the IP address of the host. Now I also need some sort of routing information. On R1, I will have the default route because I really want to send all the traffic towards this IP address here. On R2, I'm going to have the route for 10.100.100.0/24 pointing to this interface. So I'm not going to be sending this traffic down R4. And on the host, I'm going to have the default route back towards both R3 and R4, and on R3 and on R4, I'm going to have the default route back towards R2. So the reason I'm having the default routes back is because I really want to be able to ping here my, because I want to be able to ping R1's interface. So let's take a look. I have this pre-configured right now because this is not about the routing. What I want to do here is I want to test the policy-based routing, and I will show you where. But before I can actually test it, let's go ahead and see if this is configured and if this indeed works properly. I'm going to start that verification from R1. So what I want to see here on R1 is show IP route connected, and I want to see that I actually do have some routes. Actually, let me just show the whole routing table. So I can see that I have 192.168.12.0 connected directly, and I see static route, static default pointing to R2, which means that from R1 I should be able to ping, if everything is connected, if everything is configured properly, I should be able to ping my host, and I can ping my host. Now on R2, if I do show IP route, I should have the routes as I described, and what I'm interested here is the static route. I can see the route for 10.100.100.0/24 pointing to 192.168.23.3, which is my R3. And on R3, if I do show IP route, I can see the static route pointing back, static default pointing back to R2, and I can see 10.100.100.0/24 directly connected. So I should be able to ping 100 hosts from R3, and the same setup should be there on R4. So if I ping 10.100.100.100, I should be able to ping my host. So now I have my network set up properly. Let's now see where and why we could use the policy-based routing. Let's say that what we wanted to do here is, make sure that traffic coming from R1, that means from 192.168.12.1, so this is the IP address of R1, arriving on interface gigabit 1 on R2, instead of taking the default path here that we have, that is going to follow the routing table, let's say that we wanted to send this traffic down to R4, to this next hop here. So what I need to do here is I need to specify an access list that is going to define the interesting traffic, and let's say that this is the interesting traffic, and then I need to define the route map that is going to specify this as the source, and this here, this interface 192.168.24.4 is going to specify that as the next hop. And then finally I need to apply the route map to the interface. So I want to apply this route map on this interface gigabit 1. So let's go ahead and configure this. So I'm going to go to R2, and I'm going to say access list, and I'm going to use 1 permit host 192.168.12.1. So this is the IP address of my source. Then I'm going to say route map, and let's call the route map the PBR, and I'm going to say match IP address 1. So I'm saying match the access list 1 here, and I'm going to say set IP next hop, and I'm going to specify 192.168.24.4, and then I'm going to go to interface gigabit 1. Was it gigabit 1? Yes, it was. And I'm going to say IP policy route map PBR. Before I apply this, let's go to R1, and I'm going to do trace route to 10, 100, 100, 100. I want to see where this traffic goes, and I can see here that it's going to go to R1 first. That's to R2. That's what's expected. And then I can see that the next hop here is going to be via R3, because this is what the routing table says on R2. Now, let me apply this policy. So now I have applied policy on R2. And if I repeat my trace route, I can see here that my traffic now goes through R4. So I have redirected the traffic from R2 to R4. Now, I can take a look at this. If I do show IP policy, I can see which route map is applied on which interface, and I can see what's actually in the route map. If I do show route map, I can see that there is a match clause here that matches access list 1, and I can see the set clause that says this is going to be the next hop. And I can also observe the statistics here. I can see that this route map was used in policy-based routing context, and I can see that the 6 packets or 252 bytes were forwarded using this route map here. That was a relatively simple example of the policy-based route. The policies could be a little bit more involved. In our route map, we can use as the match statement, as a match clause, almost anything that the route map can match. We can match the source interface, we can match the combination of the source and destination IP address using the extended access list. We can policy-based, let's say only telnet traffic, or only ping traffic, or only HTTP traffic. So we can get very, very creative what we are going to match. And when it comes to the set rules, what are we going to override? We can either use the next hop the way I used it, or we can specify simply an interface. Instead of saying use a particular next hop, we can just tell router 1, send this out of interface, let's say serial 0. So whatever is on the other side, we don't care as long as the exit interface is this here. But there is a special form of the set statements which are designed to sort of override the default route. Now, let me explain this. When we do set IP next hop in our route map, similarly to what I have done here. So what I've done here, I have just said set IP next hop. Now, this next hop now will be unconditionally used, which means that the routing table will not be consulted, and the traffic that matches the match statement will simply be sent towards this interface here. But sometimes what we want to do is, what we want to say is, send this traffic where the routing table tells us to be sent. That means behave normally, but if you don't have a route in the routing table, in that case, send the traffic that way. In other words, we can use the policy-based route to create our own default route. Now, if the default route already exists in the routing table, the PBR will take effect before that default route is consulted. So that first part, at the first we are going to use the routing table to forward the traffic, holds true for all the routes except for the default route. The default route will be consulted if the policy-based routing doesn't match. Now, the applications of the policy-based, or where we can apply the policy-based routing, it can be on the interface, just as I have shown you now, but when we apply the policy-based route, when we apply the policy on an interface, it does not affect the locally generated traffic by the router itself. How would we then solve the problem of, for example, forcing the traffic from the loopback of R2 out of the same interface. So I want the traffic that is sourced by the loopback of R2 or any of the interfaces of R2 for that matter. I want to send this traffic not where the route tells me to send it. I actually want to send it down this interface here. So I want to override the route and routing table, and I want to send this down where my previous policy says. Now, to do that, to test how I can do this, what I'm going to do is I'm going to create a new access list on R2, and I'm going to say access list 2 permit host 192.168.0.2, which is the IP address of my loopback 0 interface here. And then I'm going to create a route map. Let's call it PBR2. And I'm going to say match IP address 2. And I'm going to say set IP next hop 192.168.24.4. So I'm pretty much setting the same policy as I had before. Now, before I apply this policy, what I'm going to do now is I'm going to say traceroute 10 100 100 100 source loopback 0, and I'm going to send this traffic where the route says. So this is where my routing table says the traffic should go, towards 23.3. But if I apply this policy here, so if I apply this policy here for my local traffic, if I apply it to be the local policy, am I going to have a desired effect? Well, maybe not, because here I am matching the source traffic of loopback 0, but not any destination. So this means that this will apply to all the traffic generated by the router by that address. This may not be what I want to do, so let's fix this. Let's use the extended access list. So I'm going to say access list 100 permit IP host 192.168.0.2, and let's say that I want the destination to be explicitly mentioned. So it's going to be 10 100 100 100 here. Then I'm going to go to route map PBR2. I'm going to say no match IP address 2, and I'm going to replace this with match IP address 100. So in this case here, I am going to apply this policy only for the traffic that actually matches this access list 100. And then I'm going to apply this policy as IP local policy and then PBR2. Actually, I have to specify the route map keyword here. So now I have my local policy PBR2 that is going to force this traffic that matches access list 100 out of the interface facing R4. So I can see here that my traffic went towards R4, but if I, for example, use the source of gigabit 1, I can see that this goes to 23.3. Now, the reason why I'm getting stars now is that my host on the other side actually doesn't have the route back for that particular network. It just has a host route for R1. But anyways, I can see that my traffic that matched the access list 100, that matched this, actually went out where I wanted it to go out. I have overridden the routing table, but the other traffic sourced by, let's say, gigabit 1 actually used the routing table. So when you're applying a policy-based route to the local traffic, you have to be a little bit careful that you don't redirect all the traffic using the policy. You just want to redirect the traffic that you actually care about.